Hi, chemistry students. In this video, we'll be continuing our discussion of stoichiometry, but focusing on limiting reactants. So limiting reactants are essentially the reactants that get used up before the other reactants, and they limit the amount of product that can be produced, right? If there's no more of that reactant, it can't react and combine to make new products. So we'll still use the analogy of in a recipe or ingredients. So we know that we can get 5 pancakes with 1 cup of flour, 2 eggs, and half a teaspoon of baking powder. Now, just like in the real world, if you go into your cupboards, you may not have these perfect 1 to 2 to half ratios to give me 5 pancakes. So you might have just, maybe you have 3 cups of flour. Maybe you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 eggs. And maybe instead of just half a teaspoon of baking soda, you have, well, this is 4 teaspoons. So this is like 8 halves, right? Because that equals 4 teaspoons of baking soda. How much could each of these produce? Well, it's a ratio. So I have 3 cups of flour, but if I look at my ratio, 1 cup of flour gives me 5 pancakes. So 1 cup of flour, 5 pancakes. And I see that 3 times 5 gives me 15. 10 eggs, well, in the recipe, there's 2 eggs per 5 pancakes. So I want to cancel out eggs. 2 eggs, the eggs cancel, gives me 5 pancakes. 10 times 5 is 50, divided by 2 is 25 pancakes. And then, if I had 8 half teaspoons, a half teaspoon gives me 5 pancakes. 8 times 5 is 40. So how many pancakes can I actually make? Well, I pick the smaller amount because the 3 cups of flour, if I convert all of that into the pancake mix, it can only make 15 pancakes. So my answer is referred to, what I do on paper, as the theoretical yield. The theoretical yield is the maximum amount of pancakes I can produce based on what I have in my cupboards. The limiting reactant is the reactant that gets used up first or limits the amount of product produced. So the 3 cups can only make 15 pancakes. It limits the reaction. It's a limiting reactant. So the flour is the limiting reactant, and my theoretical yield is 15 pancakes. Well, we can apply the same concept with chemical equations. So let's consider this reaction. I have 2 moles of carbon monoxide combining with 1 mole of oxygen to produce 2 moles of carbon dioxide. And you can kind of look at this at a molecular level if you want and think of it as, okay, well, 2 molecules of CO and 1 molecule of O2 gives me 1 or 2 molecules of CO2. You can kind of think of this bond breaking and forming bonds here to produce that. So how much CO2 would be produced if I had 2 molecules of CO but 10 molecules of O2? Well, just like we did with the ratios in the pancake recipe, I'm going to put moles of CO. Well, I know that in 2 moles of CO, there's 2 moles of CO2. So this could produce 2 moles of CO2. Well, what about 10 moles of O2? Well, if I have 10 moles of O2, and I know from my balance equation that there's only 1 mole of O2 needed to produce 2 moles of CO2, in theory, the 10 moles of O2 could give me 20 moles of CO2. So what do I do here? Well, I have to figure that the smaller amount is all I can produce. If I only have 2 moles of carbon monoxide, I'm only going to produce 2 moles of CO2 because I only have 2 carbons that are needed for the CO2. It doesn't matter that I have a bunch of excess oxygen, I still will not be able to make the 10 moles of CO2 because there are no carbons, because after the 2 carbons are used up, this reaction can't keep going. So the limiting reactant is my carbon monoxide, and my theoretical yield is 2 moles of CO2. So the limiting reactant limits the amount of product produced. It dictates the reaction. So what do we do for determining the limiting reactant in a reaction? How do we do this? Well, we do what I just did here. Basically, you know, in a limiting reactant problem, they're going to give you information of more than just one reactant. So what do you have to do? Just have to do stoichiometry twice. So this makes you really good at it because we've already learned stoich. Now you just have to do it 2 times. Why? Well, there's 2 different reactants. So you run through it 2 times and you're going to pick the smaller answer as your theoretical yield. So here's an example. How many moles can be formed of aluminum chloride if you begin with 0.552 moles of aluminum? And so right away, they're giving you not 1 reactant, but 2. So you might as well just start this at the bottom, 0.887 moles of chlorine. So just do a double stoich. So I'm going to do 2 mole ratios. So if I go here, per 2 moles of aluminum, there's 2 moles of aluminum chloride. And I don't even pick up my calculator. I just set up the next one. Per 3 moles of chlorine, there's 2 moles of aluminum chloride. Then I pick up my calculator and I perform the calculations and I get 2 answers, right? I get 0.552 moles of aluminum chloride and I get 0.591 moles of aluminum chloride. I get 2 answers because each amount of reactant can dictate a different amount of product produced. But what do I pick for my final answer for theoretical yield? I picked the smaller answer. And why is that? This aluminum gets used up once I reach that point. It can't produce any more. So the aluminum is a limiting reactant. And actually what I could write is the chlorine is an excess reactant, because a lot of times the problems say which one's excess, which one's limiting. So your excess reactant is chlorine, your limiting reactant is aluminum, and your theoretical yield is 0.552 moles of aluminum chloride. So just like regular stoich, a lot of times you go from moles to moles, but sometimes you'll go from grams all the way to grams. So it's the same thing. We do a double stoich. So what maximum amount of ammonia in grams can be synthesized from 45.8 grams of nitrogen monoxide and 12.4 grams of hydrogen? So just set up the double stoich here and make sure you're aware of your mole ratios. So when I do this, I write out 45.8 grams of nitrogen monoxide and 12.4 grams of hydrogen. And I convert the grams to moles using molar mass. So there's 30 grams of nitrogen monoxide per 1 mole. The unit of grams cancel. And then from moles of nitrogen monoxide, I can go to moles of ammonia. So there's 2 moles of nitrogen monoxide to 2 moles of ammonia. I see that here. And then from moles of ammonia, I go to grams of ammonia. 1 mole, I look at the periodic table, 7.04 grams using molar mass. And then I don't even pick up my calculator and calculate this out. I just set up the next stoich. So that's why I call it a double stoich. There's 2.02 grams of hydrogen per 1 mole. There's 5 moles of hydrogen per 2 moles of ammonia. So moles of hydrogen cancel. And in 1 mole of ammonia, there's 17.04 grams. And notice that this last half, this is why I love Stoich, is exactly the same as this one, because you're converting it to the same unit, grams of ammonia. So once you get to moles of ammonia, obviously the last conversion factor, which is molar mass, is going to be the same. So how do you pick your answer? We pick the smaller amount. So this 26.0 grams of ammonia is my theoretical yield, and my limiting reactant is the nitrogen monoxide. Do not say that ammonia is your limiting reactant. It is not. The excess reactant is my hydrogen. And that's how you identify both limiting reactant and theoretical yield in a double stoichiometry problem, which is referred to in your book as limiting reactant problems. I hope this makes sense, and thanks for tuning in. If you guys have any questions, go ahead and leave them. Thanks so much.